Welcome to our Python Basics tutorial. In this session, we'll cover foundational Python concepts, especially focusing on how these basics are used in machine learning. Whether you're new to programming or just starting with Python, this tutorial will guide you step by step through the essentials. To begin, you'll need to download Python. Head over to official website and get the latest version 3.12.6 or 3.10 are recommended. If you're using an older version like 3.0 or 3.1, it's best to upgrade. Python is compatible across different versions, but for this tutorial, we recommend the latest stable releases. Once you've downloaded Python, you'll need an environment to run your code. Idle is a great tool for beginners as it offers an interactive shell where you can test out Python commands. You can use the GUI version or the command line depending on what you're comfortable with. Python relies on indentation to define code structure, unlike languages like Java or C that use braces. This means how you format your code directly impacts its meaning. Let's see an example. How the indentation indicates block structure. If you're familiar with other languages, this is an important shift in mindset when coding in Python. Also, as you see, a hello world program on screen. So is about print statement in other side. As you see, the calculating the square of 12 and another statement is x divide by 2, you get the output 72. In this Python code sample, we begin with a simple arithmetic operation, x34 minus 23. This subtracts 23 from 34, resulting in a value of 11 for x. Next, we assign the string hello to the variable lie, which we'll use later in the code. After that, we assign a floating point number, 3.45, to the variable z. Moving forward, we encounter a conditional statement that checks two conditions, whether z equals 3.45 or if y equals hello. Since both conditions are true, the code inside the if block executes. In this block, we add 1 to the value of x, changing it from 11 to 12. Then we concatenate the string world to the existing value of y, which is hello. As a result, it now stores hello world. Finally, we print the value of x, which is 12, and the value of y, which is hello world. This simple Python example demonstrates basic operations like arithmetic, conditional checks, and string concatenation, all while handling both numbers and text seamlessly. In Python, indentation plays a crucial role in defining the structure and meaning of the code. Blocks of code are organized through indentation, which signals hierarchy and scope, unlike some other programming languages that rely on brackets. Variables in Python are created simply by assigning a value to them for the first time without needing to declare their type, as Python dynamically determines the variable type automatically. When it comes to assignment, Python uses a single equal sign, while comparisons are made using double equal signs. Arithmetic operations like addition, subtraction, multiplication, and division are performed using symbols such as and as expected. String concatenation is done with the operator, and % is used for string formatting, much like in C's printf. Logical operations in Python are represented with words like and, or, and not, rather than symbols, making the code more readable. Lastly, Python's basic command for outputting text to the screen is print, which is essential for debugging and displaying information during code execution. Python uses several built-in data types. The most common ones include integers, floats, and strings. You can assign variables without explicitly declaring their type, as Python automatically infers the data type from the value. Example code showing integer division, float assignments, and string concatenation. The default type for numbers is integers, which are whole numbers. For example, performing integer division such as z equals to 5 divided by 2 results in an answer of 2, as Python performs integer division. Floating point numbers, or floats, represent numbers with decimals like x equals to 3.456. Another essential data type is strings, which are used to represent text. Strings in Python can be enclosed in either single or double quotes. ABC is equivalent to ABC. Strings allow for unmatched quotes inside them, for example, maths, which includes an apostrophe within the text. For more complex situations where both single and double quotes need to be included, or when dealing with multi-line text, Python allows the use of triple double quotes, like a BC. This flexibility with strings makes Python well suited for working with text in various formats. In Python, whitespace is crucial, especially for indentation and new lines. Code blocks are defined by indentation, not braces, and a consistent indentation is necessary. Use new lines to end lines and use a backslash when continuing a line. The first line with less indentation ends a block, while more indentation starts a nested block. Colons mark the beginning of new blocks, like in function definitions or clauses. Definitions or clauses is enforces readable in structured code. Comments begin with hashtag, and the rest of the line is ignored by the interpreter. You can include a documentation string, docstring, as the first line in a function or class to describe its purpose, enclosed in triple quotes. This is useful for development tools, debuggers, and makes your code easier to understand. Good practice includes comments to clarify complex code and docstrings to explain function behavior, like returning the factorial of a number in an example function. Assignment involves binding a variable to hold a reference to an object. Assignment creates references, not copies. Variable names in Python don't have intrinsic types, the objects they reference to, and Python automatically assigns the type based on the assigned value. A name is created the first time it appears on the left side of an expression. Example, x is equals 3. References are deleted through garbage collection when the names bound to them go out of scope. Python follows reference semantics. Python has certain naming rules for variables. Names are case sensitive and they can contain letters, numbers, and underscores, but they cannot start with a number. Also, some words like print or for are reserved keywords. The Python community follows certain naming conventions to make code more readable. For example, function names are usually in lowercase with underscores between words, like my underscore function, while class names follow studly caps, like my class. Python allows you to assign values to multiple variables in one line. This is useful when initializing multiple variables at once. You can also easily swap values between variables. It's important to note that trying to access a variable before assigning a value to it will result in an error. Python won't allow you to use variables that haven't been initialized. Now that we've covered the basics, these concepts lay the foundation for Python's role in machine learning. You'll frequently use variables, data types, and logical operators in machine learning models. As you advance, you'll build on these principles to work with libraries like NumPy and Pandas.